Hello, everyone. My name is Zach. This is Science Explosion, and we are at Hudson Public Library in Hudson, Iowa. So I think this is going to be a pretty short one today, but today's theme is math. Now, don't go running because I know some people are a little bit afraid of math, but I think when you look at math the right way, it can be a lot more fun than you think it is. And don't worry, we're not going to be doing any calculations, anything like that, just a little bit of measuring. Now, this specific branch of math is one that I think is really interesting. It is, what is it, topology. So not quite topography, but it is basically the talking about the surfaces of things. So even more so than the surfaces too, we're going to be talking about how changing the way that something is twisted can change the way it is. All right, so it'll make sense when I show it. So take a piece of paper. The supplies you'll need for this one are pretty simple. You'll need a paper, pencil, scissors, and it'll help you if you have something like a straight edge to draw with. So if you have a ruler, you can make this work, or even better, if you have a square like this, that'll make it easier. You don't necessarily have to have one, but trust me, it'll make this a lot easier. So first of all, before we get started, I want you to think about this piece of paper. How many dimensions is it? All right, so you might have heard people talking about axes, and some people that helps them to think of it, so I'll talk about that. But if it doesn't, you can just ignore that part for now too. So dimensions are the ways that you can measure something. So if you've got a line, that's one dimension because you can only measure it going one way. Now this paper, you could measure anything on its surface in two dimensions. So I can do this way and I can do this way. So this would be like the x-axis is like the length of it, and this is like the height of it. That's the y-axis, okay? So that's just a thing to keep in mind. All right, so I have got what our final product will look like here. Oh, the other thing you will need is a round object, like a lid. So this is just a butter jar lid that I got from one of the Hanson's butters. So I'm guessing a lot of people have one of those lying around. But any round one like this, it needs to be sturdy. You can't just cut this out of paper because I want to show you that this isn't a trick. All right, so right here, we have got a regular piece of paper that I have cut a square out of on this. And I've got this, my round lid. Now, I want you to notice the size of this lid. It is very, very clearly bigger. So this is a square here. It's 5 by 5. And this is about 8 this way and 8 this way. So my challenge to you is fit this through this piece of paper. All right, so I'm going to show you how to set this up yourself. And while I'm doing that, I want you to think a little bit about how I'm going to be able to fit this through this piece of paper. I promise you it's possible. Now, don't rip the paper because that would be cheating. All right, so you're going to take your piece of paper and it's going to start to feel a little like origami here. You're going to fold it in half. So I'm folding it hamburger style. And then you're going to fold it in half the other way as well. So like hot dog style. Although at this point it looks like it's just folding it two hamburger styles, but I don't know if people still say that. That's what teachers used to say when I was a kid. So if when I say that, teachers don't say that anymore, and that's confusing, that's okay. You fold it the long way and the short way. All right, so, okay, yep. So now you've got it folded in half twice like this, and I've got my square here, which is going to make it a lot easier. Oh, I think I doubled what I said this one was. This is not 5. This is, I think, 2.5 by 2.5. And this one, now that I'm looking at this one is 4.5. So this is 4.5 inches, the length of this, and this is 2.5 inches, the length of this. All right, so the easiest way that you can get a nice perfect square on this is to take this corner here. So you see, if I fold it like this and like this, cut out from here, this corner. So that's going to be the corner where you'll make one cut and it'll cut right in the middle. So you see the ones where it's just the single sheets of paper where it doesn't have anything folded, the opposite side of that, so this one. Now, take a look at the size of your lid. And if your lid is like 4.5 inches, like mine, you're going to want to make the length of the line that you're doing on here on either side just a little more than half. So I'll tell you what I mean by that. So my lid is 4.5 inches long. So I made my lines here at 2.5. Actually, was that 2.5 or was it 2.25? Yes, I did do 2.5. So I'm making a line here at 2.5. And a line here at 2.5. So you can see I did lines like that. And then going to make my lines, trying to keep this straight, go out all the way. Ooh, sorry, I actually told you wrong. So that's going to be the total length of that. So I think what you actually need to do is make it half of what I just said you. So sorry about that. So the total length there is 2.5, but actually you're going to just want this to be 1.25. So half of half. So 1/4 of that. All right. So 1.25. Sorry about that, everybody. I think I was confusing you there. I was thinking a step ahead. I'm going to leave this in the video, though, because I think it's important to realize everybody does make mistakes. That helps you to visualize it a little more, too. So to go over that, since I know I said that in a little bit of a confusing way, this is 4.5. So take half of that size, just a little more. So I said 2.5. And that's the size of the square you're going to want to cut out. Now, if you're cutting it the way I am to make it easier on myself, you're going to want to cut that in half again. So that's 1.25, that's half of that. So this square should be a little more than 1/4 of this. So 1, 2, 3. I should be able to fit just a little more than 4 of those along the length of that circle there. All right, so then you're going to cut that out. Be careful to try to cut it right along there so that you are not cutting past it. You don't want this piece of paper to rip, because I want to show you that this is math, not magic. All right, so then it'll look like that. And when I fold it out, you can see I've got a lovely square there. And you can see it's about the same size as the last one I made. So since I just made this one, I think I'm going to work with this. So as you can see, again, I'm going to hold this up right next to there. You can clearly see that this is still much larger than this opening. So how do you think it gets through now that you've had a chance to think about it? All right, so I think what most people first want to try is putting it through these corners. And you can tell that's not even close to going to work. So before I show you how, I want you to really think about this. So you've got this object that is pretty much flat. We could even cut this down so that it was this lid part, so it was a 2D object. It's not the fact that this is 3D that's stopping it from getting through. And then we've got it trying to get through this 2D object. So this is a 2D object pretty much trying to get through this, another 2D object that is a smaller opening. So that's my last hint for you. The problem is this is a 2D object trying to go through a smaller 2D object. All right, so remember I talked before. You've got the x-axis, the y-axis, so there's more than that in real life. So we've been treating this paper as a flat object, which right now, aside from these kind of janky looking folds right here, it is. But we need to turn it into a 3D object. So you've got the x-axis, the y-axis, but now we need to work in the z-axis. So that's going from this way to this way. So it's like length, height, and width. All right, so the problem is this is 4.5 inches, and this side from here to here is 2.5 inches. And this from here to here, I'll let you figure that out yourself, actually. This is 2.5, this is 2.5. So this from here to here, if you know, I bet some of the older people can already tell me at least how to figure this out. If not, I'm sure you will learn this in school, the adults in the room watching this. So a squared plus b squared equals c squared. So 2.5 squared plus 2.5 squared equals the square root of this side. So you'll find out that is still less than 4.5 inches, which is why that doesn't work. So you're never going to get it to fit through these corners. But think about this side is 2.5, this side is 2.5. When you add them together, you get 5, which is definitely more than 4.5. So you're probably thinking to yourself, well, Zach, those two sides are in different places. How can I possibly get them to go together? You need to stop thinking about this as a two-dimensional object and start thinking of this piece of paper as a three-dimensional object. So you're going to fold it over like this. So now you can see so if you fold it over so that the corners here and here meet each other, this is also a really good way to see why you're never going to get it to fit through the other way, because I can put those right next to each other and you can clearly see this is way bigger than will fit in there. So I've got this side, this is 2.5, this is 2.5, but now here is where the magic of this really starts to come together. You've got to fold them like this. All right, so you might not have seen quite what I did there, but basically, if you get it so that it's like this, so it can move a little bit, and then take this and be careful not to rip it, and then go down, and then as little space as you can on the folds for this part. All right, so I'm going to push that down so I can flatten it out a little bit. So I'll show you that again. It was like this. You're going to bring it down like this, and you can see from this side that it's got these flaps right here, and then I pushed it this way. All right, so now it'll look a bit like this, and let's see if I can get this to go through here. My guess is yes. So I'm going to push this through, and bam, it goes right through. And if I put this down at the length that I pushed this through, I can see that it is just long enough. All right, so I'm going to show you from this side too, so you can see what it looks like where I am here. Would have helped if I'd done this with a different color, but you can see I'm pushing it through. And it's definitely not ripping. It is going all the way through. And I can easily pull it out. So you have actually made this line right here, the hole in this, larger in 2 dimensions than it was before by making this piece of paper go into 3 dimensions. So it's thinking in a higher dimension. So I just think this one is fun because it doesn't, even when you've done it, it doesn't look like it should fit. So I can always just put that. You can see there's no trick. Feel free to try this at home. I'm putting it in there and then sliding it right through. And you can show this to your friends, try to get them to do that. All right, so that's how to think in higher dimensions. This was 2D, you made it in 3D, so 3 dimensions. Now my challenge for you is, can you think in higher dimensions than that? So remember you got X, Y, and Z. So, X, Y, and Z axis. So length, width, and height to figure out how big things are. But can you think of any other dimensions than that? So if you're saying where something is, that's all you really need is those 3. I could tell you just with those 3 things if you have the right reference point where anything in all of space is. But you've got a bit of a problem here if I'm telling you that. That just tells you where it is. All right, so the way I said that, can you tell what the 4th dimension is? All right, so it's time. So if you think of time as another dimension, think about these like coordinates or where something or how to find something. So the first 3 are the where, the last one is the when. So if I were to tell you go to length, width, height from a certain reference point, you'd be able to find it. But if I had something there that you needed to pick up on Tuesday, April 11th, well, then you'd need to know that information as well. So those are 4 dimensions. All right, so now I want you to think higher than that. I want you to try to imagine 5 or more dimensions. What would they be like? Now, if anybody wants to look into things like string theory, there are different ways that a lot of theoretical physicists talk about higher dimensions than just our regular 4. So if you want to look those up, you can, but I want you to try to use your imagination. What would it be like? Now, also imagine, what would it be like to explain those to someone else? So if you want to think about that, how would you explain us living in a 4D world to somebody who didn't live in a 4D world? Or even excluding time, how would you explain moving around in 3 dimensions to somebody who lived in 2 dimensions on a flat surface? All right, so that is it for this week. This has been Science Explosion. Remember, we were talking about topology today, which is a very specific kind of math. I think it's a really fun one. If you want to look those up later, there's lots of fun topology experiments and thought experiments as well that you can look into. All right, so thank you very much. My name is Zach. This is Science Explosion at Hudson Public Library, and I hope you join me again next week. Thank you. Bye.